Hey, welcome back to Gabversity, where facts care not about your feelings. We are celebrating with some beautiful universal coffee. It's delicious. And we can talk about the galaxies as we're doing so. And let's see who pops up and who doesn't pop up. So, star systems like our Milky Way, Mr. Fun Guy. Oh, well, Scott, wow, that was quick. Scott, Jerded, that's fantastic. All my Patreon people, my GoFundMe people are all here. It's great. So star systems like our Milky Way contain a few thousand to tens of billions of stars. And Fun Guy is my retweeter. He's one of the retweeting engines. Witty chick, lovely to see you. Now this is a beautiful way to study. I now have the umbrella up because it is just way too hot. Have a look at this. I now have to have this up because that sun is, oh my god. It is out here. It's going to hit 100 degrees today. 110 actually. And it's our third week of spring, as I just said on Gab Life. So I finished my Gabulous breakfast, and of course Periscope cut out, so I said, alright, we'll come over to Gabversity and begin our lecture on galaxies. So, I'm seriously thinking about doing the greatest calculus course ever. I've been thinking about that, but I've got to get a Patreon account for Gabversity, and people have to be interested. So far I've only got 2 people interested. I have to get like at least 10, otherwise I can't do it. I'll just have to go back to driving trucks. Or selling books. Ah, yes. Alrighty. So, tens of billions of stars, large variety of shapes and sizes. Okay. Tens of billions of stars, if anyone can even understand what the hell that means. Tens of billions. So, you can have up to 100 billion stars. What does that even mean? What does 100 billion mean? You could count. You would die before finishing counting the stars. The human being couldn't even know what was there. So it's just insane. And then out of those galaxies, there's 100 billion of those galaxies, which each contain 100 billion stars. And we now know, like as humans, and I've said this before, we now know that each of these stars has at least a planet. And so, what's the chance that one of those planets doesn't have algae on it? Which may one day be able to make intergalactical coffee. Intergalactic. Tactical, hey. Where are you that it's daytime there? It is in Sydney, Australia. Where else is it daytime at the moment? In Sydney, New Zealand, they're a bit ahead of us. And further up north from us, what's that? Parts of eastern Indonesia, Japan, parts of Russia. Yeah, so not many of us live in this time zone. All right, galaxy diversity. Ooh, galaxy diversity. All right, so even seemingly empty regions of the sky contain thousands of distant galaxies. Spirals, ellipticals, irregular, and some of them are interacting with each other. You're in New York. Awesome. New York. So, well, you guys wouldn't be familiar with galaxy diversity. Lovely to see you. The Hubble Deep Field, 10-day exposure on an apparently empty field in a sky, revealed hundreds of thousands of galaxies. Hey, lovely to see you guys. I love it. It's great. See, all of us around the world are talking about the galaxies around the universe. It's great, isn't it? Each one can represent a galaxy. I just can't even comprehend it. Our brains can't comprehend it. There's no way until maybe artificial intelligence will be able to learn and go travel and see what's happening with life. And all these other places. And by that time, the Earth will be united. It'll be like one country. But then there'll be other planets, so that'll be like, and then like our cousins on Mars will laugh. Yeah, I know, I can't do it. And then, the people on Mars will go, look at the Earthlings, and then Earth will have their president and Mars will have their president. Is it a good thing or a bad thing? I think it's neither. I think it's neither, because, you know, I mean, if we remember, tribal warfare, it's relative to how far you can travel, given the technology that you have. I've said this before. So as technology advances, the size of our domains increase. Hopefully you'll be dead. Yeah, it's the same. It's what they call, say, same parents, different address. We also say same shit, different smell. Accent sexy AF. You know what's hilarious? My accent is not Australian, even though I'm Isaac Asimov books. Even though I've grown up in Australia my whole life. People are like, oh, are you sure you're from Australia? I'm like, yes, I'm from Australia. You sure? I thought you're from South Africa, or maybe, you know, Britain or something. I'm like, no, I was born and raised in Sydney, bitches. Anyway, but one of my scopers said it's probably because I speak 6 languages that all of the accents mess up. Yeah, I'm not sure. But the birds are gone. See, it's too hot even for the birds. They're like, oh, get out of here. Oh, it's too hot. All right, so highly elliptical is E7. You do a great, thank you. Yeah. Hello, I am Nikolai. I like to impersonate Australians. 6 languages. Yeah, I have a channel called Six Lang. Sixlang. Speak American. America. Where's my Hemi? This summer, I will drive her Hemi. Yeah. All right. So E0 means it's spherical. E7 means it's highly elliptical. Now, there's a mathematical reason for that. That's because if anyone's done basic maths, they know that the formula for a circle is x squared plus y squared equals r squared, that's the formula for a circle in Cartesian equations. Bye. But an ellipse is x squared over a squared plus y squared over b squared equals c squared over whatever. Z squared over d squared or something. Or you could just say it equals 1 if you want. That's probably easier. All right. So for a spiral, SA means it has a large nucleus. Oh, I'm sorry, Dan's not here either. My brother's called Dan. All right, so SA means that the galaxy has a large nucleus, which means it's got a big bulge in the middle, my friends. That's SA. All right, so SC has a small nucleus. It's got small little ball in the middle, and it's got really long arms, right? Yeah. So what do we got here? Gas and dust in galaxies. We have spirals are rich in gas and dust. Hey, Pablo. Hola, Pablo. ¿Cómo estás hoy? Yo te quiero. I am Puss in Boots. I am Pablo. Check out the rims on my car, essay. Alright, so spirals are rich in gas and dust. Ellipticals are almost devoid of gas and dust. Now that's probably because they're really, really old galaxies. Galaxies with disk and bulge but no dust are termed S0. That's where we're headed in like 5 billion years, when the Andromeda galaxy and our galaxy intertwine. And that's going to look pretty cool for any of our descendants. Imagine looking out at space at night and you see the galaxy when it gets really close before it combines with us, and you're just going to see this Andromeda galaxy like right in our face. It's gonna look insane for our descendants. If you go to YouTube and look up Vsauce Andromeda galaxy, you'll see it. They take a photo of what it's going to look like. It's going to be phenomenal. All right, so barred spirals. Barred spiral galaxy, Andromeda. Oh, sorry, close. Andromeda, M-E-D-A, I think it is. M-E-D-A, Andromeda, yeah. I used to call it as a kid Andromeda. Hello, Andromeda. How are you? I'm good. Okay, got it. Bye. Bye, True Faith. Thank you. Lol. Alright. So the bar galaxies are SBA, SBC, same deal. So they're all like that. You got S0, you know, which is no spiral, then S1, S2, S3. As you go down to S3, the arms get really long, like an octopus. Same deal with the bar spiral galaxies. So the bar ones, I just realized the bar galaxy looks like a logo for something. Does anyone recognize this? I've seen this before. Grandma, is it? Oh, okay. I didn't even know that. Look at this, that, and that. This is a logo for something. Is it Samsung? No, that's not the Milky Way. This is a bar spiral. So I don't know what's... Man, I'm gonna see that. We don't know. Yeah, I'm gonna see it somewhere and I'm gonna remember and I'll run back to GABversity. Ooh, I still have some coffee left. This will be called one day Earth coffee. You've seen it. Quasar. Irregular galaxies. Irregular. It's a vortex. Irregular, that's like us, because we're all watching GABversity instead of Falling Cats. We are irregular galaxies, often result of galaxy collisions and mergers. They're like, don't know where. I'm telling you now, I've seen it. So irregular galaxies are galaxies like train wrecks. Well, I didn't see the stop sign. Man, what you talking about, fool? Stop sign right in front of you. Yeah. They collide on a regular basis. Yeah, apparently they do, but define regular. Like, they take millions of years to actually collide. It's like a slow motion accident. It's like, no. And then a million years later, and a million years. So they take a long time. All right. Dwarf galaxies are satellites of larger galaxies. Watch where you're going. Watch where you go, fool! I'm so sorry, I didn't see you. I was looking at your abs. You know. All right. So some galaxies orbit other galaxies. This stuff just blows. How can we even contemplate this stuff? All right. So distance measurements to other galaxies. We use the Cepheid method. Right. And basically that one's actually pretty interesting. The Cepheid variables. Right. What we do is we use parallax, which I've mentioned in other lectures, to get ourselves to the nearest Cepheid star. And then from there, we use that star as a torch to get us to other stars. So it's like using rulers on top of rulers. You put your ruler on my ruler. All right. What we do, okay, so for those, banter is fun. Welcome back. So for those of you who have been in the last astronomy lectures, this is for you. Find its luminosity. Right, so we get the Cepheids period, right? It's that time of the month, and then we find its luminosity and we compare it to its apparent magnitude, and then that's how we find its distance. Hey, Mileno Chica, I'm Mileno Chica. Hey, banter is fun. The G host. There are too many jokes with the G host. Do you have trouble finding the G host? Millie. Hey, Millie. Oh. Alrighty. Cepheid distance measurement. Repeated brightness measurements of a Cepheid allow the determination of the period and thus the absolute magnitude. Now, this is really important, right? We can go all day with the G host. Ah, ghost. Is that what it is? A ghost. I went the G host. I don't know why. Anyway. So Cepheid variables, because their brightness is almost identical everywhere in the galaxy, so it's very easy to know that if they are darker, they must be further away. If they are brighter, they must be closer. That's the thing. Whereas with regular stars, you can't know, because if a star is darker, it could be either further away or it could be smaller, like, or less bright. You don't know which one. But with Cepheids, because they're constant, then you can fix that constant and know. Can you do lessons on vortex math in a future time? Good question. I would love to do more lessons. I might set up a Patreon account, I think, and I'm going to build it up. And once we have like enough members, then I don't have to drive buses, because I've got one for Gabsmacked, and they're helping too. Like, I get like $100 a month from them, which means I can take one day off from work. And then I might do it with this, because I really, really want to do like calculus from beginning to end, like from 1 + 1 calculus all the way to calculating black holes and what happens at the center and how time slows down and all of that stuff with advanced calculus. I would love to do that. It'd be crazy. Can you imagine? Like, someone rocks up to GABversity and they've never done, Marley, what's up, man? Good to see you, love. No, now I sounded Irish. Oh, you know that thing I was telling you about the other day? That's the Irish people. Has anyone heard that joke by Billy Connolly? Your coding. Ah, see, he's working on a secret mission to get people out to Venus so we can learn more about women. See, this is what I mean. We're all sitting here having coffee, and freaking Marley is like out there. Did I say Marley or Marty? I always forget. Anyway. Alright. Stopping in to say hello. Well, hello right back at you, Marley. Always a pleasure. Good luck with your coding. I look forward to seeing the I look forward to seeing the what do you call it? You know what I'm talking about. Alright. Distance measurement using type 1a supernovae. Alright, another important thing. So here I'll give you an example. So I'm going to pick two people here. So let's pick Scott and Millie. Alright. Marley, I did say it Irish, yeah. You know that thing I was telling you about the other day? You know that Irishman? Come over here and having some Guinness with me. I find it so fun to talk to. Anyway. And then there's the Scottish ones, like, give him a two, fire-breathing horse, any day of the week, laddie. Alright. I'm sure they don't talk like that. They always say that. They always say to me, you don't talk like that. What was I going to say? So yes, so we have Scott and Millie, and the lights are out. All right. Now, Scott's married, so I'm not saying anything, right? But the lights are out. Now they both have candles, right? Now we can tell that Millie is further away because her candle is weaker. Peace. Good luck with your coding, my friend. Pleasure to see you. All right. So, but the problem is that actually that was a trick. It turns out that Scott was actually behind Millie. But Millie had a smaller candle, right? And that is not a dirty joke, right? So, in other words, it's very hard to tell in the dark who's actually before whom unless you know the candles are the same brightness, the same size, right? That is the point. Okay, and that's why we can use type 1a supernovae, because they're identical everywhere around the universe. Okay, so observe apparent magnitude and distance, and then we figure out their absolute magnitude. Yeah. The most distant galaxies. Only the general characteristic of galaxies can be used to estimate their luminosities. So for example, okay, I'm going to show you a photo of a cluster of galaxies that are 6 billion light years away. In fact, the light that's reaching us now left the galaxies before the Earth even existed. Have a look at this. This is, look, they say 4 to 6, like that's the estimate, right? 4 to 6 billion years. So we don't even know, we wouldn't even know what they look like now. In fact, just to give you an idea, the light took 6 billion years to reach us, but this is going to mess with you. This is going to mess with you. Even though the light took 6 billion years to reach us, the distance between us and that star now, and those clusters now, are more than 30 billion light years. How does that make sense? How does it make sense that those stars are 30 billion light years from us, but it only took the light 6 billion years to get here? Right? How does light travel faster than light? That doesn't make any sense. Right? Let's see if anyone actually knows the answer. I'm sure. Hey, Josan. Hello, I am Josan. Alright. So, expanding universe. Damn straight banter is fun. Of course banter would get it. I should have said everyone can answer except for banter. I'm drunk, I'm super confused. Don't worry, we're not drunk and we're still super confused, so it's all good. It's all good. So that one, yeah, that one's a hard concept to explain if you haven't seen it, but it's sort of like this, like light is running on a treadmill that's going the other way. So, you know, like if you're on a treadmill, you were going to say that, so cool. So if you're on a treadmill and you're running, right, and the treadmill's going the other way, right, then you're running heaps, but you're not moving forward very far because it's going backwards. And that's what's happening with the universe everywhere. So it's all expanding from each other because all of the gaps in the universe are getting filled with dark energy. The dark energy is seeping in from outside of the fourth dimension, and it's coming in everywhere, because we are a four-dimensional universe, so all of the rips in the universe are everywhere amongst us, because we live in a pixelated universe. So between every pixel, you could get out hypothetically, that's like complete garbage. That's not scientific what I'm saying. I'm giving you an analogy, right? And within those gaps seeps through this energy, and it floods in, and it spreads us out even wider. Yeah. Man, the problem with astronomy is that there's too many euphemisms, sexual euphemisms. All right. So, talking about, all I have to say right now is universe is awesome. Dark energy sounds sinister. I know. Hola, I am dark energy. I will find you, and I will kill you. Good luck. I have a unique set of special skills. Anyway. All right, so the universe, the further away we look, the faster the universe is expanding. In fact, right at the edge of our horizon, how about folding time? Is that a typo, or is that a really funny joke? Good luck, Pana said Russian. Yeah, good luck. Good luck. Hello, I am Nikolai. Yeah. What are they? Spasibo, пожалуйста. I know a bit of Russian because when I was learning to fly a plane, my instructor was Russian, and he's like, whatever you do, like we're in the sky, right? And he's like, whatever you do not push this button. Привет, привет. Też nie по-русски. Kazdila. No, Kazdila, what's that one? Yeah, that's right, Kazdila, how are you? Anyway, yeah, and he's like, do not push this button. He goes, I will show you what happens if you push this button. I'm like, please don't push the button, man. I'm flying the plane. No, I will show you. I will push the button. So he pushes the button. Oh, contributors, thank you. Yeah, dela. Как дела? Как дела? Yeah, you know, it's funny, like we stereotype people, but sometimes they are exactly the stereotype. Like my pilot, he was a nutcase, man. He pushes the thing and the plane starts diving. I'm like, why are you pushing the button? Anyway, so there you go. I got really sick that day when he pushed that button. And then when I used to teach at the library as a volunteer for refugees. I used to teach refugees English because I could speak Arabic, so it was a massive help to them. And the librarian was Russian. And it was so funny because she was like this massive like chick, right, with like almost like a crew cut hair, and I don't even remember her name, but she was like, "Hello, what do you want?" Like, but then as soon as you go, "How are you?" she'd smile, "Hey," but if her face resting, oh my god, man, I didn't want to mess with her. So the Hubble constant, Sonia. The Hubble constant is 70 kilometers. So what's that in miles? 6 5s, 6 5 30, 6 4 is 24. So about 45. Let's say 45 miles per second per megaparsec. Okay, and a megaparsec is about 327 million light years, I think, something like that. Is it? No, 3.27 million. So 3,270,000 light years, something like that. Anyway, so that means that the universe further away from us is expanding faster and faster per second, 45 miles per second. So as we're talking, the universe is stretching at 45 miles per second, per parsec. So the further away, you're looking at millions of miles per second. In fact, it's expanding so fast that light from there will never reach us, never. So there are universes out there that we will never be able to see ever until we can, build wormholes. All right. And then we have a gigaparsec, which is a billion parsecs. Okay. So, hey, Muhammad Cheren. Hello, I'm from Turkey. Merhaba. Caligula. Alright, so vastly different sizes and luminosities, from small, low luminosity, irregular galaxies to giant ellipticals and large spirals a few times the size of the Milky Way. Yeah, some of them are gigantic. Rotation curves of galaxies. Rotation curve is the rotational velocity versus the distance from the center of the galaxy. Now, this is something that's interesting. The rotational... Is that Animal Farm? Have I not seen you for a while? Hey, Rescue Farm. Long time. I haven't seen you in ages. Didn't get the Turkish one. Damn it. You are better in the Russian. Yeah, I know. I got to get better with my Turkish. Oh, all I know is teşekkür. Hello, I'm from Turkey. They have this. I haven't. Anyway, we'll get there. All right. So what's interesting is that the galaxy rotating, right? The edges. Ah, you are too kind. I'll have to get better. Oh, I speak a good English. I went once to Shanghai, and then I just learned like 天道你很高兴. That's it. That's all. And it's really bad as well. All right, so no offense to Turks, but I speak Greek better than Turkish. Too funny. By the way, I'm having Turkish coffee, but you know what's interesting? If you go to Greece, it's called Greek coffee. If you go to Lebanon, it's Lebanese coffee. If you go to Israel, it's Israeli coffee. It's very funny. All the countries that don't like each other all share the same coffee. Totally following you while drunk. Damn straight. I hope that works. All right, so what's interesting is that the further we get, the further we get away from the center, you would expect things to flow slowly. But what's going on is the speed is wrong. The speed is so wrong. In fact, it's rotating at such the wrong speed that the galaxy should be blown apart, and it doesn't. And so they figured out that there must be a mass that we can't see. In fact, it's most of the mass. Everything that makes us up, everything that we call real matter, that lives on the atomic table, whatever you call it in chemistry, excuse me, atomic calendar or whatever it is, all of that only makes up 4% of the universe. Antimatter. Even antimatter, everything, all of that makes up 4% of the universe. The rest is made up of 96% dark energy and dark matter, and no one knows what they are. They just infer their presence because something's going on. It's sort of like, imagine going into a room and then every time you put a cup on the table, it gets knocked over and there's nothing there. You think it's a ghost, right? So it's like ghost matter or ghost energy. Okay, determining the mass of galaxies, we use Kepler's third law, which I taught you guys in a lecture a little bit before. All right. Okay, so the elliptical galaxies are up to 50 times the mass of the Milky Way, and about 5 times as bright. That can go up to that level, and 5 times the diameter. The spiral one's not as much. Time travel, I want time travel. I did speak about that. If you go to my quantum mechanics lecture on light, I'm talking about the nature of light. It's probably 4 or 5 thingamies ago. You can have a listen. And now we're going to get into supermassive black holes, and then we'll probably end this scope soon. So supermassive black holes, okay, they are several million or up to 1 billion times the mass of the sun, right? And we found that most of the mass is invisible, which I've already said. Some ideas could be brown dwarfs, small black holes, exotic elementary particles. Yeah, go have a look. It'll be a lot of fun. You'll enjoy it. Gravitational lensing. I think I said warning, there's a lot of maths, and then I never did any maths because people were asking really good questions. Gravitational lensing. Okay, so we spoke because our universe in 4 dimensions is warped, right? Which means that time does not flow evenly. It actually bends light because light doesn't have mass. So how can you bend it? It's like trying to bend a ghost. Well, you bend the 4th dimension itself, and that's what's causes light to bend. Okay, and then that way you can detect dark matter and black holes. Is it in reply? What did you call the scope? It was called the quantum definition of light or something like that. Something like that, yeah. Galaxies generally do not exist in isolation, but form larger clusters of galaxies. So they all hang out together. Oh, you're always welcome, Millie. Rich clusters, 1,000 or more galaxies condensed around a large central galaxy. Just like us humans, they like to hang out together in groups. All right, poor clusters, which they're sort of like the loser crowd, you know, sort of like, I used to hang out by myself at school, mostly. So sort of like my side, where we had poor clusters, generally not condensed towards the center, they just sort of hang out. There's no central figure. All right, our galaxy cluster, the local group. So our local group, we've got the Andromeda Galaxy, the Small Magellanic Cloud, the Large Magellanic Cloud, and the Milky Way. Neighboring galaxies. So Sagittarius Dwarf Galaxy is hard to see because it's sort of closer to... I would totally hang out with you out of school. You are too kind. Where the hell were you 20 years ago, my dear? All right. The Canis Major Galaxy. All right, I'm probably going to stop here. Simulations of galaxy interactions. Oh, that's awesome. Mergers of galaxies, starburst galaxies. We'll probably talk about them later. And then we'll talk about supermassive black holes, radio galaxies, Seyfert galaxies, the farthest galaxies. We'll get into that later. All right, well, that was a lot of fun, guys. Thank you very much. Pleasure to see you all. 20. How old am I? I am 36.7 years old, my dear. Touch wood. And yes, people tend to freak out when they find out my age. I'm very lucky. I think it must be the autism. If you want to know, for those who are new, I would recommend going. You're 26. Oh, that's all right. So you're only 10 years younger. So if you go to Gabsmacked on YouTube, GABSMACKED, type in Gabsmacked and then type in second live autism speech. You thought you were the same age? Oh my God, I love you now. Thank you. You have made my day. All right, ladies and gentlemen, lovely to see you all. I'm going to get cracking. But if you go to this... it's blinding out here. Off topic, I read the book. It was great. Thank you, Scott. That's awesome. I'm making an audio book soon. And they're sending me a second-rate actor to actually read the beginning and the end. And I'll be reading the rest of the book. I'll probably scope to my Patreon guests like my friend Scott as I'm recording the audio book. All right, love you all. And don't forget, if you want, go to YouTube. Otherwise, get the book. And that's about it. Remember Gabversity when I watch the replay. Thank you, Millie. Likewise, I like you already. Go and watch, Gabversity where facts. Deltron, my friend, another awesome quiet achiever, just like Scott. Don't care about your feelings. Facts don't care about your feelings. Hey. GG. Nice meeting you. Likewise, Millie. Me leave a